so let's look at number 1. For these, we have to solve each equation using a common base. So we want to change 81 to be 3 to some exponent. So let's see, 3 to the first power is just 3. 3 to the second power is 9. 3 to the third power is 27. 3 to the fourth power is 81. So we're going to change out this 81 to be 3 to the fourth power. What do we do once we get the same base? Cancel them out. Okay, so we set the exponents equal. We have negative 3x minus 3 is equal to 4. There we go. And now we add 3. So negative 3x is equal to 7. And now what should we do? Divide by negative 3. So x is equal to 7 divided by negative 3. Alright, let's do one more with a common base. So let's look at number 3. We want to change 25 to be 5 to some exponent. So 5 to the first power is 5. 5 to the second power is what? 25. That's perfect. Exactly what we need. So we're going to change 25 to be 5 to the second power. What do we do once our bases are the same? Cancel them out. And then we just set the exponents equal to each other. So negative 2x minus 1 is equal to 2. What do we do from here?
Plus 1.
Add 1. So negative 2x is equal to 3. And then 1. Divide by negative 2. So x is equal to 3 over negative 2. So you could write it as 3 over negative 2 or negative 3 over 2 or negative 3 over 2. It doesn't matter where you put the negative, they're all the same thing. Let's look at number 5. So here we have different bases. So we can't get this 72 to look like a 9. It's just not possible. So what do we have to do to solve when we have different bases? Log of what base? Awesome. Whatever this number is, that's what we use. So log of 9, log base 9 of 9 to the power of 9m. And then what we do on one side, we have to do on the other. So log base 9 of 72. So what happens here when we have log base 9 of 9? They cancel out. So then we're just left with 9m is equal to log base 9 of 72. Now from here, we have to put this into our calculator. So how can we do that? So we put this in the calculator as log of 72. The big one goes on top. The base goes on the bottom. That gives us 9m is equal to 1.9463. What should we do next? Divide. Perfect. We divide our decimal by 9. So divide both sides by 9. So we get m is equal to 0.216. All right, let's look at 7. So again here, we can't get the 9 to look like a 16, so we have different bases. So what do we have to do? What do we do when we have different bases? the log on both sides. Log with what base? Awesome. Whatever this number is, that's our base. So log of 16 to the power of 4v is equal to log base 16 of 9. So what happens on the left side when we have log base 16 of 16? They cancel out. So then we're just left with 4v on the left side. And then on the right side, how can we put this into the calculator? What's our change of base formula? Perfect. Log 9 over log 16. So we're going to say log 9 divided by log of 16. We get 4v is equal to 0.79248. And then what should we do next? Divide by 4. So we get v is equal to 0.198. All right, let's look at number 9. So here we're solving, but we have a log equation. So anytime we have more than one log on one side, we want to condense it down to one log. So how can we combine these two together to just be one log? If we're adding, what goes with addition when you're condensing? Multiplication, perfect. So we have log of 5 times 3x. So we just condensed it to one log. This is equal to log of 23. What happens when we have a log on one side equal to a log on another side? What do we do with those logs? Cancel. They cross each other out. So if you have one log on one side is equal to one log on the other, it's like having the same base like we did here, where we just canceled out the 3's and canceled out the 5's. We just cancel out the logs and set everything else equal to each other. So 5 times 3x is equal to 23. What's 5 times 3x? 15x. Just multiply 5 times 3. So 15x is equal to 23. And then what else do we have to do to solve for x? If 15 is being multiplied to x, what's the opposite of multiplication? Division. So we divide. So x is equal to 23 over 15. Any questions on that one? All right, let's look at number 10. So again, we have 2 logs on one side. What do we do when we have 2 logs on one side?
Combine.
Combine how? If we're adding, how do we combine them?
Subtract.
What goes with addition when you're condensing?
Multiply.
Multiply. So we multiply 5 times 4x. And that's equal to log of 9. What do we do when we have 1 log on one side and 1 log on the other? What happens to the logs? They cancel. So 5 times 4x is equal to 9. What's 5 times 4x? 20x is equal to 9. And then what else do I have to do to solve for x? Divide by 20. So x is equal to 9 divided by 20. All right, let's go to number 11. So again, I have 2 logs on one side. How do I condense these now that I'm subtracting? Divide. So log of 2x divided by 4 is equal to 2. How can I get rid of this log here? What's my base? Remember, when there's no base written, what's your base? 10. So what big base do I need to put here and here to get that 10 to cancel out? 10. So I make my big base 10, and what I do on one side, I have to do on the other side. So 10 to the power of log base 10 cancels out. So I'm just left with 2x divided by 4 on the left side, and 10 to the second power on the right side. Now what's 10 to the second power? 100. What else can I do to solve for x here? What was that? Times 4, perfect. Since 4 is being divided here, I multiply it to get rid of it. So 2x is equal to 400. And then what else do I have to do? Divide by 2. So what's 400 divided by 2? 200. So x is equal to 200. That's my answer. So let's look at number 12. So I have 2 logs on one side. What do I need to do to condense it? If I'm adding, what do I do? Multiply. So 5 times x plus 10 is equal to 1. What do I have to do next to get rid of that log? So I want to make my big base whatever the little base is here. So what's the little base here? 10. Remember, when there's nothing written, that's a little base of 10. So I make my big base 10 and my big base 10. So 10 to the power of log base 10 here cancels out. So I have 5 times x plus 10 is equal to 10 to the first power. What's 10 to the first power? Just 10. What should I do next?
Distribute 5.
I can distribute the 5. So 5x plus 50 is equal to 10. What do I do next?
Subtract 50.
Subtract 50. So 5x is equal to 10 minus 50, which is negative 40. And then what should I do?
And divide by 5.
Divide by 5. What's negative 40 divided by 5? Negative 8. Awesome. Good job, guys.